Okay, what we're doing is section 3.5 in the Algebra 2 textbook. I want to choose x values and end up with y values. I think I want ones that have perfect squares, like 0, 1, and 4. If you put in a 0, square root of 0 is 0, and 0 times anything is 0. If you put in a 1, the square root of 1 is 1, so you have negative 4 times 1, which gives you negative 4. If you happen to put in a 4, you'd end up with negative 4 times 2, which is negative 8. So when I graph this, 1, 2, 3, 4, I really want to use ones that have perfect squares or square roots, like 0, 1, and 4. So when I plug these in, I get 0, 0. And I get, let's mark some off here, 1, 2, 3, 4, 5, 6, 7, 8. And so I'm going to go through 0, 0, 1, negative 4, which is about here, and 4, negative 8. Where it becomes essential to know is what the square root looks like. If it was just the square root of x, it would look like this, half of a parabola. This one is the bottom part because of the negative in front of it. And it might be a little wider because the number 4 is bigger than 1. But you should know what a square root looks like, and hopefully what a third root looks like, because other than that it's just shifting. Once you learn what these look like, it's not too bad to get a visualization of the graphs. For example, this one is a square root of x, so I know it would be like this, but it's negative, so that means it's probably down here, right? So that's pretty much all you got to do. I would like some points. If you put in a 0, you get out a 0. What do you get if you put in a 1? What's negative 4/5 times square root of 1 is 1. So you would have 1 negative 4/5, right? What would you get if you put in a 4? What's the square root of 4? And when you multiply top times top, bottom times bottom, you get negative 8/5. So if that's 1, 2, 3, 4, this would be 4 comma negative 8/5. You may notice I did not increment my y-axis. That's fine as long as you label your points. I don't increment my y-axis on many of these because sometimes the y values get very, very big or very, very small. Okay, we did a couple square roots. Let's do another square root. Again, I would use values such as 0, 1, and 4, maybe 9 to get to y because they have perfect square roots. If you put in a 0, the square root of 0 is 0, so it goes through 0, 0. If you put in a 1, 5 times 1 is 5, so it's going to go through 1 comma 5. If you put in a 4, square root of 4 is 2 times 5 is 10, so it's going to go through 4, 10. If you put in a 9, square root of 9 is 3 times 5 is 15, so it'd be up here, 9, 15. And it's just like the square root graph. It goes forever to the right, but it has an endpoint on the left here. Now we're going to look at some cube roots again from 3.5. Cube roots, I would use values that have cube roots, like 0, 1, and 8. Cube root of 8 is 2. 2 times negative 1/7 is negative 2/7. Cube root of 1 is 1. 1 times negative 1/7 is 1/7. Cube root of 0 is 0, and 0 times negative 1/7 is 0. So it's going to look like a cube root, but what's that negative going to do? It's going to make it more like this. So it's going to look more like the black one. But anyway, it goes through 0, 0. And I didn't do negatives. You're right. I should have done negative 1 and negative 8. That's just going to be changing the signs on these. So it's going to go through 1 comma negative 1/7, 1 comma negative 1/7, 8 comma negative 2/7, and if I put in a negative 1, it'd be at 1/7, negative 1 comma 1/7. If you were to put in a negative 2, you'd get out a negative 2/7. Now you can see why I didn't increment my y-axis, because all those values are between 0 and 1. So sometimes it's easier not to increment and I'm wrong, it's not negative 2. What am I putting in? A negative 8, and that'd be more like over here, right? So this would be 8 comma negative 2/7 over here. But it does look like this. How about this one on number 19? If you put in a 0, you get 0 minus 1, which is negative 1. So I notice it goes through 0, negative 1. I notice that it is a cube root, and it's going to do this. The minus 1 moves it down 1. So I already kind of know what it looks like. Are there any questions? Feel free, we should put in some values, like 1 and 8. Actually, let's do them in order. 1, negative 1, 8, negative 8. Put them together. If you put in a 1, 1 to any power is 1. 1 times 3/4 is 3/4. 3/4 minus 1, which is 4/4, gives you a negative 1/4. So I put in a 1, I got a negative 1/4. 1 would give me a positive 1/4. That'd be these values. 1 gave me, hang on. Oh, that's because it's the minus, so I didn't go far enough. That would be down here and here. But if you put in an 8, I bet you get a positive. What's the third root of 8? 2. 2 times 3/4 is 6/4. What's 6/4 minus 4/4? 2/4 or 1/2. So it would go through 8 1/2. It would go through negative 8 negative. No, it wouldn't, because that's shifted down. Those are not going to be symmetric. Let's put in a negative 8 and see what we get. What is the third root of negative 8? Negative 2. So if you took negative 3/4 times negative 2, the negative times a negative is a positive. That would be 6/4 or 3/2 minus 2/2. Is that right? Let's take a look here. You're putting in a, because it's negative, that's a positive, so it's a negative, that makes a negative 5/2. So this would be negative 8, negative 2.5, or negative 5/2. I'm more concerned with just getting the shape down than the actual very, very specific points. But I am trying to teach you to plug in values that have third roots, if it's a third root, or values that have square roots, if it's a square root. Now we have a couple more to look at here. We'll look at 15. It's a third root, it's a positive, so I already know it's going to do this. If you want, I'm pretty happy if you know that it does this. There's no shifting, it doesn't add anything or subtract anything at the end. The 7/9, if you really want to know, 7/9 is less than 1, so it makes it a little bit less steep. It's very tighter, basically, closer to the y-axis. This is a negative third root, and it's so instead of a third root like this one over here, the negative third root does this. What does a minus 6 do? Moves it down 6. So it's going to look like this. Again, I'm not too concerned with the graph, the specific points. I'm more concerned with what it actually looks like.